I'm Matthew Ismail. I'm the person present in the room, obviously, and I am the conference director here at Charleston and the editor of the Charleston Briefing, a short book series. And so I am the person who's present and will moderate to the extent that we need moderation. And this is Anita, who will now introduce herself. She is in Denmark, I believe.
Yes, correct. Now, people can hear me. Can they also see me? Because I only see you. So, okay, good. So I can't see the audience, but I can see you. So
if I could change that, I would.
So hi everyone. It's lovely to finally be in the room virtually. So my name is Anita Schön-Abigod. I'm the CEO and co-founder of Iris.ai. And as was mentioned, I'm currently in Denmark. I'm Norwegian national, and I've lived a little bit all over the world. And I'm currently, as I said, running Iris.ai, which is my fourth own startup. So startups and technology and entrepreneurship is very much my thing. And we'll talk more about Iris during the session, so I will leave it at that.
We're in an informal channel, Anita, so I'm going to record. But it's going to be me recording. Maybe I'll give it to you. So the meeting today involves AI, in which Anita is an expert and I am not. But I'm interested, and I think that's something that's common among many of us, that we hear about AI all the time. We hear about how it's going to have an impact on our lives. We hear about what it's doing to us and the dangers and the benefits. But what do we really know about it? What is it, precisely? When someone says artificial intelligence, and you ask them for a definition, well, frequently the definition of artificial intelligence is as confusing to the non-expert as is the artificial intelligence itself. They use a lot of terms that I don't understand to describe something I don't understand. So I thought what we would do is, instead of starting by asking Anita to define AI, would just sort of give us an example of how things have changed in the artificial intelligence world from something that I can kind of understand, which is the old expert systems, to the current world of machine learning. So I'll just hand that off to Anita to explain this transition in a way that may give us non-experts an idea.
Yeah, so I'll try. I'll do my very best. So the fact of as you said, artificial intelligence is a very broad umbrella term, and it means absolutely everything and absolutely nothing, and it really depends on who you ask. It's great for kind of general. We're in this scientific discipline, but it doesn't really take us any further than that, and it really depends on time frame, point of view. If we talk about artificial intelligence 20 years from now and AI today, those are also going to be two very different things. And in fact, what you mentioned, the expert systems were kind of the artificial intelligence of the 80s and 90s. And I'm not going to bore you with a long history lesson, but it is really interesting to kind of see this hype cycle of artificial intelligence coming and going, and neural networks and deep neural networks, which is what is happening right now. That was actually invented, 30, 40, 50 years ago, but wasn't really implementable until recently. So what happened, and what you're asking about, is these expert systems, right? That were very popular in the 80s and 90s. They're still widely in use because they really work for some tasks. And what an expert system is essentially exactly what it sounds like, which means an expert, a human, have sat down to build a set of rules of the world, right? So that could be, let's say I wanted a system which was not something that was not possible with expert systems, which was systems of, for example, recognizing that a cat is a cat. It's trivial to a 3-year-old human to recognize that a cat is a cat. But if you wanted to have an expert system do that, well, you have to start making these rules, right? So what are cats? Well, they've got 4 legs, they've got fur, they've got a cute little nose, Well, so does guinea pigs. Um, cats are skinnier than guinea pigs, unless they're pregnant. And then you start building these rules, and it turns out human reality is really complex. And if you want to build these rule systems for what the world is like, you very quickly get into like these massive and if or but crazy networks that just isn't, and then suddenly like a mouse comes into the picture and then this whole cat rule set is ruined, right? So reality is complex, and these expert systems were great at simple tasks, right? If you could encode a set of rules for, there's quite a bit of trading, financial services, right? Where you can set, you can set a rule set that kind of covers most scenarios, and it kind of works, and it's much better than doing it manually. And for a lot of kind of specific, simple tasks, expert systems were great. However, it didn't scale well, and there's a lot of context, concepts. For example, recognizing objects in images, like the cat example, where that just wasn't enough, right? So in 2007, 2008, it was deemed that things like recognizing that a cat was a cat, or recognizing, a human being in a photo, that just was too hard for a machine to do. But then what happened in about 2012 was that we suddenly had, as a kind of whole human species, we had enough computational power, right? Our computers were getting more powerful. Moore's law, for those who know that, but that's basically, our computers are getting, smaller and smaller and more powerful and cheaper, which is very convenient. And suddenly we had these really powerful machines that kind of anyone could use. And thanks to the internet, we had all of this data available to us. And then we could take some really old technology and actually apply it to challenges that weren't covered by expert systems. And basically the fundamental difference between the machine learning and the deep learning systems, which is just a form of machine learning, if you like, the basic difference is that the expert systems has an expert that has defined the rules. But for a machine learning, neural network, deep learning, whatever you want to call it, these are interchangeable terms that overlap a lot. These systems has in common that you give these systems a data set, let's say 1 million images of cats. You may or may not have labeled those, depends if you do supervised or unsupervised learning, but let's not go into that. But you give that system 1 million, 10 million images of cats, and the system teaches itself over time, based on feedback, to recognize cats, or to even, as we see these days, for those who've seen DALL-E 2 and Mind Journey, to even generate pictures of cats, which is even the next stage, right? So these systems basically take everything we feed it and make sense of it on their own. That's the same for, and now I'm used images as an example, but it's the same for text, right? Natural language processing, understanding of language, where rather than taking kind of the linguistic approach, which is like, I am now going to encode every single grammatical contextual rule there is in this universe, which would take us some time, and probably not be possible with a rapid change in the language. Rather than saying that, we're saying we're giving this machine these massive data sets of text, and we're telling it to learn context on its own. And that's how you had, so with images, you had this thing called ImageNet, which was one of the breakthroughs. With human language, you had Word2Vec, which is basically, in some ways, turning language into math. And that sounds a little bit weird maybe, but that's essentially what we as a kind of research discipline has done. We've turned language as well into math, and we can now kind of run math queries on language to understand it. Still rudimental, still getting there, but that's what we're seeing right now. We have this like scalability where we as humans are not the ones that have told these systems exactly what, linguistic rules or rules for cats are. Hopefully that made some sense. It's a very exciting time to be working in AI.
I think it's always much easier to understand moving from rule-based systems like expert systems to systems that scale based on experience. And
Yeah.
that's kind of where we are. And I think it's what's interesting for, and I'm sorry, Anita, you can't actually see people except me. I don't know how to reverse this. The company Anita founded in 2015, it's called Iris.ai, is a scholarly communication, is about the scholarly communication environment. And what I would like to have Anita explain, where did Iris.ai come from? What were the challenges and the issues that she was facing that led to the creation of Iris? And what does the system do? We'll get to a demonstration after that.
Yeah, so I'll try to keep a long story short, which is always a little bit difficult. But you know, if we go way back in 2012-13, I was running this company. We were doing heat exchanger network optimization, right? Super technical, super scientific. We'd gotten this old piece of software from a consultant. They didn't quite know who had made it, but we're like, okay, we can make this work. Turns out there's kind of some serious science going on behind the scenes here. Let's find that science. Let's find that information, that knowledge. Someone must have taken this, communicated it on the internet. Surely there's information out there. And I sat down, this was kind of in the field of thermodynamics, and I sat down in front of Google Scholar and I'm like, thermodynamics? I had no idea where to start. And it took us 9 months. And finally, it turned out the guy that actually invented the method had published papers on it and had written the code. He was 3 blocks up from us at our same university. I didn't know, and I didn't have the vocabulary to find him. I knew it was out there. I couldn't find it. And that was one experience. And then a few years later, in 2015, I went to this summer program where they challenged us to come up with these ideas that would positively impact the lives of a billion people within a decade. And we sat and looked at different angles and like what are some of our fundamental challenges. And one of the things we kept coming back to was, you know, essentially scholarly communication or science and research and this like fundamental knowledge that is being communicated to the world, but it's becoming increasingly impossible to navigate. So that's kind of where we decided, okay, let's do something about that. If we can make every single kind of scientific and research insight from academia, from scholarly environments, and make that actionable for anyone who's trying to build on it or implement it, well, we can solve a lot of problems that way, or be like the enabler of problem solving. So that's kind of how we started it from a real kind of deep-seated frustration with putting research into practice.
So basically, Iris.ai came about not because you were an artificial intelligence researcher looking to make a company, but because you were doing other things and encountering so many difficulties with all the research that's available. You didn't have the sort of searching expertise. Even if you did, it would take a long time putting keywords into Google and seeing what comes up. So Iris is a response to starting a research project and having such a huge amount of work to be done just to get started, much less to digest everything you find. So let us see how we can I make you the presenter? I'm sorry we have to.
I can probably do like that.
Yeah.
Will people then see?
Yes.
Yes.
Well done.
Good. Good. All right. So if at any point something freezes or you can't see anything, let me know because I don't get visual feedback of what's going on. But Let me do, I'll briefly introduce it, and I won't do like a full demo today, we do not have time for that. I'll just briefly introduce you so you get a feel for the things we're working with now, because then we can kind of have an interesting discussion about the future as well, and what we think will be possible, further down the line. So, as you heard from the introduction to why we're doing this, it's all about finding the right research knowledge. And obviously, what everyone thinks when they hear that is search, right? Better search. And that's true, but I would say that much like artificial intelligence means a lot of different things to a lot of different people, search is also one of those things where we kind of get what you mean, but it's a lot of different things to a lot of different people. So to give a couple of examples of what we're not doing, which are, I would say, problems that have already been solved long ago because of the internet and digitalization. So for example, if you know exactly the article you're looking for, so what was that guy's name or that gal's name, title was something like this, you go to Google Scholar or whatever Expo or whatever, whatever search engine of preference you do, and you type in those words and maybe like half a spelling of the name of the author, and you'll find where you're looking, right? That's not the problem. That's already solved. Now, likewise, perhaps surprisingly, going from, let's say, a full communication, database of, let's say, 50 million articles, and narrowing that down to just the 5,000 that are relevant in your field, that's also not that hard, right? Couple of keywords, you got a nice collection of 5,000 documents. That is also not anything that we're trying to solve, because those are straightforward. But there are some distinct search challenges that are really, really hard. And I'll show you a couple of examples briefly about how we go about that. So first of all, the Iris.ai platform is an intelligence layer, meaning we don't actually have any content. The content can be connected from other sources. So universities' own repositories, open access databases, patent collections, anything that has that scholarly, academic, scientific type language. We don't work with a citation system. We don't work with predefined keyword by the authors. We look at the actual content of the articles. So in your, what we call your researcher workspace, you will have all these content collections going from, 50 million articles in one collection. Here's PubMed, so it should have about 28 million articles. All the way down to much smaller content collections. You could also upload a Dropbox folder of 10 documents, and that can also be a content collection. For the demo, right now, I have a content collection here that has about 5,000, 6,000 documents. That was all about libraries, right? So I did a quick search, found 6,000 open access documents on libraries, and that's my starting documentation, and I want to filter it down. Now this is where it gets complicated, right? Because I can't now just go in and look for keywords like libraries, right? I have to have smarter tools to be able to narrow this down quickly and not, go through the headline of 5,000 articles, because that's going to be a really boring exercise. It's kind of like building an expert system. It's going to take me a lot of time. So, a couple of things we can do, and I can't show you all of the features, but a couple of things you can do with this reading list that has 6,000 articles, and I really want to narrow it down. We have an analyze tool that will enable you to look at what are the most, for example, what are the topics of this data set? And I'll show you what a topic looks like. It's a string of 10 words that put together represent a group of documents. So here we can see, of these 5,800, we have 260 documents talking about university, users, quality, performance questionnaires. Okay, we kind of get what that topic is about, right? We have one that is about, librarians, researcher liaisons, workshops, etc. And these topics are a really good way to kind of figure out what's going on in my data set. So that's one thing. Another thing, I'm going to disable that one. A couple of other filters that we have is a word analysis. So for example, I could simply do librarians and libraries. These are not keywords. These are concepts where the tool has a lot of information, a lot of contextual information about concepts. But they're still kind of word-based, right? Now, what if I really wanted something contextual that was hard to put into words? Well, what I've done here, I decided to look for diversity and equality in the library context to see if I could find research on that field. So what I did is I wrote my own statement, 100 words or so, about what diversity is. I wrote it, or I made a copy off the internet, just as a, a definition of diversity, right? What is it that we're looking for? And you can see it here, right? So this is my own copy paste into the tool, and I'm matching it against all of these documents in the tool. And I'm ending up with looking for librarians and libraries and diversity. I'm suddenly ending up with this list of 116 documents that has to do with, let me actually sort it by match score with diversity. And we can see here, we see social change in academic libraries, right? Very much related to diversity. It does not have the key term diversity in it, but it is very much an article related to it, right? We have creating a social justice mindset, right? We have social competencies of the librarian in education, etc. And one I thought was really interesting too, see if I can find it, one that was about historical trauma, indigenous people and libraries, right? It doesn't actually say the word diversity, but it is very much related to how we build our libraries. All right, so this is a way to really very, very quickly, without building out keyword queries, to rapidly narrow down the data set to exactly what you're looking for. Another couple of things, another type of search that I think is really important, especially when you deal with interdisciplinarity, or if you're a younger researcher that you don't really know what you're looking for yet. There we have this concept of a visual map. So what I've done here is I've taken a research article I found that was about academic librarians working with LGBTQ patrons. I actually took that one, gave just the URL to the tool to read, and I built this map. And it's a visual map that I've matched the text of the original article to about 50 million research papers to go broadly and explore. So for example, I could look at LGBTQ and information seeking and have articles in that topic. Or I could look at, librarians and, research practice or academic education. And I'll find, articles from that angle, and this way look at the problem from very, very different angles. This is really good for broadening my, to remove the, I can't remember what they're called in English, the things that horses wear to not see it wrong. Blinders, thank you. So that's a couple of the things, just to give you a feeling for it. There's also, there's a couple of other areas. It's also related to finding the right information. We also allow people, for example, to summarize. So this is actually kind of on the forefront of natural language processing. We can write summaries of research papers, either of the full text of a research paper or multiple ones, right? So you can get summaries of, let's say, 10 research papers in the same domain, and you can actually very quickly read through it. We also have something called the extract tool, which is especially more for medical research, for material science research, where there's a lot of experiment data in the articles. You can actually pick or create your own Excel sheet of these are the data points I'm looking for, like what's in this material, how do you make it, what are the properties? And the tool will actually extract this from all of the articles you choose and systematize it into one Excel sheet. And these are also ways to not search, but find the right information also within the research papers themselves. So some of these tools are, or all of these tools are kind of very complementary to the research tools that we're, or the search tools that we're used to using. The only thing I would like to wrap up on is that, as you might have noticed, we do not do recommendation algorithms. We do not say people who search for this article is also looking for this one, because that fundamentally, disagrees with the notion of doing research, right? You're not looking for what everyone else is doing. You're looking for information related to your research challenge. That's why we think recommendation algorithms is not the way to go for scholarly research. So with that, I will stop my screen sharing. Hopefully that was a quick overview of some of the challenges for scholars.
I think that's great, and I think, one of the questions, because I want to leave a little time for questions, and it's, yeah, I think we're done at 9:15, so I want to just, if you could just quickly give us an idea where you expect AI-based machines to transform scholarly communication in the next 5 or 10 years, and then we'll get to some questions.
Yeah, so if I start with what we're trying to achieve, I can't speak for everyone else, but what we're trying to achieve with our AI systems is to build what we call a questions and answerings machine based on assignments, right? So rather than saying, I need this and this and this article and this data from the article, I could rather flip it around and just really post my specific, clearly defined research questions. Like, is there a material that has the property of X that would be useful for Y? And then actually the machine doing what I just showed you on its own and finding you that information. That's what we're working on, longer term, 10 years into the future. In general, a few of the things that I think are going to happen, not just based on what we do, but like on the field of AI and machine learning in general, I think the citation system is going to radically change. Obviously, you want to cite the people you actually refer to, right? But like this idea of building this massive citation graphs at the end of your paper doesn't really make sense. Citing people because they're the most cited people, yeah, that part is going to go away. The popularity context. I think we can do peer review a lot smarter today, and I think we can actually change the incentive system of peer review, but that's more my personal agenda more than anything. I think the idea of impact factor, I think we need a proper, and we will get a proper revamping of what does it mean for a paper to actually be impactful to the field. Again, removing the popularity contests from it. I also think fundamentally that what we're looking at is a future where the format of a research paper or a conference proceeding is going to radically change, right? We have different ways of tracking scientific and research contribution, not with AI, but for example, kind of blockchain or other immutable ledgers. And I think the combination of that with smart tools for analyzing it means that we don't need this like, I have now published a paper and it's going to be here for eternity with exactly that conclusion. We're going to be able to do a lot smarter things in how we share kind of scientific and research output. That's more the result of technology, not what the technology in itself solves. But that's some of the trends that I'm seeing and that I think will be possible.
I think you've pretty much touched on many of the things that everybody sees as a problem. Everybody wants to deal with. I'm sorry, I'm speaking to you on this thing. But it sort of speaks to the potential rather than just the huge claims about creating robots that will interact with us and take our jobs and whatnot. It allows us to talk about the problems that are ongoing, that we continually see people talking about peer review, about journal format, about how publishing is going to change in rather than just creating PDFs, what's actually going to really change publishing. So dealing with concepts rather than keywords, allowing machines that can search and collate information based on concepts so that you don't actually have to know the keywords. So it's all something that I think could be really transformative. So let me stop talking now and just say, do you have any questions for Anita? Please. Oh, I'm sorry.
We'll try to go quick. So we talked about this not being a recommender system, but my understanding, which is very minimal, of artificial neural networks is that they are based on relationships between, in this case, maybe topics rather than users. And so my question is how you prevent established topics, things that have more of those relationships from being privileged and potentially innovative topics from being deprioritized.
Yes, so to give a proper answer to that, we would need probably an hour. But no, you're right? So the broad claim of like not doing recommender systems is that we're not saying, well, because you click on this article, the next researcher that types in the same keyword are gonna wanna click on the same article as well, right? So we do absolutely none of that. Now, when we go to a deeper kind of analysis of it, right? What the machine does, it maps out the context of all of the vocabulary that is being used. And one of the challenges of that is dealing with what's called out of vocabulary terms, right? Meaning, for example, words that are used in one very specific context, but that isn't used in the same way or isn't used at all in other contexts, right? Or words that are coming in as new terms, right? I mean, I said blockchain, right? At some point, Bitcoin came in as a term. It wasn't a term already, right? So how do you incorporate that? And we are solving that in a variety of different ways by looking at how to grasp those out of vocabulary words. One thing we've done, and I'll try to keep it short, is that especially when we have clients that are not necessarily a full university that kind of has a broad spectrum of research, but either a university in a specific domain, or we also work with R&D organizations that have like, well, we do steel research, and that's what we do. What we do there is that we actually reinforce this kind of general language model that has a broad understanding of science. We reinforce it on that specific company's research field, or that specific department's research field. And that's where you kind of capture those new terms, the terms that have a different meaning in that field of science. And that's really, really important to be able to like not just follow the overall trend of the language. And it is also an ongoing challenge to get that as nuanced as possible. But finally, whenever, like every time a new research paper is published and it's being put into the Iris system by a user, we pick up the vocabulary there. So if the word Bitcoin appears, it will contextually be linked to blockchain. And the more times the machine sees it, the more it includes it in the vocabulary.
What's the Iris business model?
Did you go to Iris business model?
Yep. So we sell software as a service licenses to universities with academic pricing. So usually university libraries. And then we sell it software as a service as well to R&D departments in larger and smaller companies. So usually per user seat, per full university library for the libraries, or per extracted document as well for the more computationally heavy parts of the process.
Anything else? We have time for a question or so. Well, I think so.
Just another question, but there are also other emerging tools, like for example, a listen that it's also a research assistant with AI. And I would like to, are you familiar with Elicit?
I didn't hear the name of the company, so probably not, but if you can spell it, I might.
Elicit.
Elicit. Okay. Yeah.
And I am wondering, it's confusing to know what each does, or so.
Yeah.
Oh, okay. No, I just thought that so yeah. So I don't have a question because.
Busy with
No,
their
I
own
mean-
company.
Look, and in fact, it's like we've been doing this since 2015, right? When we started this, there were no one else. IBM Watson made a lot of bold claims about what they could do. They couldn't, and they still can. When it comes to this field, is my role statement back. But besides that, there were very few other players. Now, what we're seeing now is, there's a ton of new players. There's another Norwegian company called Kenius that's also making this little plug-in that you can sit, and when you write something in a document, you have a little plug-in that will recommend articles. But it's based on what you write, right? So it's very, very similar to our kind of initial technology as well. right? There's all of these startups popping up. They're realizing that this is an important field, and not to get too kind of deep into it, but it's been very, very hard to find investments for tools that go into scholarly communications because the venture capital world says, oh, research, well, there's no money in that, is there? And it's really hard to get funding. So I'm really glad to see all these new players popping up and coming up with solutions. So I think it's a good thing, right? If what we've done and what others have been doing, and we've published a lot of our AI research, open access, right? So others can benefit from that. You know, if at the end of the day we don't succeed commercially as a massive success, but there's like 15 other companies that do well, that would make me really excited. So at the end of the day, to go back to what may be your question, is like, how do I know what the difference is? I mean, test the tools, right? See what you like. It's also about UX. It's about good support. It's about, you know, who do you trust? It's about knowing the owners of the company, perhaps. Is it, you know, is it Google or is it, you know, a small startup company? Where are they from? Like, there's a lot of factors in that. One thing I did want to mention, in case some of you jumps on our website and see that there's like this login button, that's for some of our old tools that are still available. What I showed you today is a new tool that is going to be launched within the next, it's already available for individual organizations, but not for individual, you know, single users. So if you do want to test the new tools, it's better to send me or the company an email. I just wanted to make sure that too. If you're curious to go in and test tools, you can do so on I mean, these other companies will also have demo versions, right? So it's really at the end of the day what you like working on, right? What works for you and your use case.
I know that I do want to say something about identifying researchers. I still feel that this is really challenging to, you know, distinct researchers, not by name or, so I wonder what you think of it and how can we better do a, you know, identify researchers not by only names and even not only by subject or their titles.
It'll be very quick because we've already reached our time. And I don't want to be, I actually don't want to keep people who are coming for the next presentation. I think that's not fair.